Next, we're going to sketch the graph of the function and its inverse function. So for this example, sketch the graph of the functions and their inverse on their same axis. So for the first function is a quadratic function. So you'll notice that quadratic function, it only takes a part of it, which is x greater than 0. So for quadratic function, you can see this is negative quadratic, means it is graph masam. Alright, and then your maximum point is 5, and then your x value, you're computing the square here, x without any value means x is 0, y is 5. So it intersects on your y-axis at 5 here. So the whole graph, it will be like this. But you'll notice that the condition from the question they're asking here is drawing for x greater equals to 0 only. So when x greater equals to 0 means only this part. Because only this part can become 1 to 1. Only this part, when we remove this part, then this graph can be 1 to 1, so it can be inverse. So now we draw on our axis. Maximum value is 5. So later on we plot out the roots. Okay, so in order to get inverse function graph, we need a axis of refraction. So this refraction axis is y equals to x. So y equals to x is a straight line with 45 degree. So if cannot get 45 degree means you will divide this quadrant into half. So into the symmetrical pattern. So here will be 45. So this is the axis of refraction to get our inverse graph. So now I back to my graph. So the graph of quadratic only show on this x greater than 0. So the quadratic graph is going to curve down. Maximum value is 5. The roots here, it will be square root of 5. So how to get, so this is our function. We label it first x squared plus 5, where it only involving x greater than 0. How to get inverse function? So inverse function, we're going to reflect this function using this refraction axis y equals to x. Then the result of the refraction will be our inverse function of graph. So kita akan pantulkan graph ini menggunakan pasi pantulan y sama dengan x. So bahagian demi bahagian. So untuk sini, untuk belah sini, bila dia pantulan, dia akan turun ke bawah. So here is our value of 5. So untuk ekor sini, bila dia pantul, dia akan ke sana. So intersect at square root of 5. So this is our F inverse graph. So make sure you label origin to show that this refraction axis pass through origin. Then we go to second graph. Our function here is gx equals to 1 over x minus 3, where x is greater than 3. So rational graph. Rational graph, we find out the domain, where the domain is the denominator cannot be 0. So x minus 3 cannot be 0. X equals to 3. X cannot be equals to 3. So the value of 3 will be our asymptote. Meanwhile, for range of the function, kita tutup dan kita tengok, kita tutup rational ni, kita akan nampak nilai kosong di luar. So y is not equals to 0. So our asymptote occur at y equals to 0 and x equals to 3. So rational function is a reciprocal graph. So positive rational means your graph will be located at quadrant 1 and quadrant 3. So this is supposed to be your rational graph without xy axis. Only I showing you is asymptote. But for this question, condition for the question is ask us to show only for x greater than 3. So for x greater than 3 means they are asked you to draw on this part only. They want this part only. So this one we no need to show. Then we set up our x-axis, y-axis, drawing back your asymptote, horizontal asymptote, where y equals to 0. You can see range is not equal to 0, so your graph is not equal to 0. No graph cannot touch 0, so it will be the line for our asymptote. X cannot equal to 3. So x equals to 3. So our reciprocal graph will be occur on here. Okay, so the graph will near to the asymptote and we curve, then they near back to the asymptote. So this is our reciprocal graph for 1 over x minus 3 for x greater than 3 part for the first quadrant part. So the quadrant no need. Then we set up for refraction axis. So refraction axis, it will be occur at y equals to x. So it will divide the quadrant equally. Label this refraction axis y equals to x and label the function just now is gx equals to 1 over x minus 3 for x greater than 3. So based on this refraction axis, now we're going to refract every part of this graph gx so that to get f inverse. So one by one. For vertical asymptote, when you're going to refract x equals to 3, so occur at here. So this is, ini pasti pantulan, so pantulan akan berlaku di sini. So pantulan vertical asymptote, it will become horizontal asymptote for f inverse, which is occur at here. So label x equals to 3 now become y equals to 3. So this x equals to 3, I already refract using y equals to x, so it become horizontal, y equals to 3. Now I'm going to refract the horizontal asymptote y equals to 0. So y equals to 0, it touch the refraction axis at here. So here will be occur the refraction. So horizontally now will become vertically x equals to 0. So this is how I refract for my inverse function for its horizontal asymptote and vertical asymptote. Now I'm going to observe the graph. So the graph. So for this part, touching the refraction axis at here. So here will occur our graph, refraction of the graph, which is going near to the asymptote. going near to the asymptote. So for this part, going near to the asymptote here. So finally, so this is our G inverse. So label origin. So make sure your graph is in label, your asymptote is in label for inverse function and the function, x-axis and y-axis also.